Okay, hello everyone. Welcome to this opendronemap tutorial. And then in this tutorial, we're going to use opendronemap to create high quality ortho photos, and then to create the 3D models using the software, and then explore it using this 3D viewer module in this software. So as I go through, we will use these tools to, for example, make points, to explore the total views, and then zoom in, zoom out, maybe using these tools, measure distance or the height of a pile of asphalt. So as information, the opendronemap, unlike drone2map, it is open sourced software, so you don't have to pay for using the software, but it uses Docker, and then you need to run the software in a Docker container, and then you will manually copy all the required file from GitHub repository. So let's go from the installation. So to use this software, you need to install it, of course, and then it provides an installer, but it costs money, so we'll skip that. Before installing, I recommend you to check the hardware recommendation. I don't think it will be a big issue. The processing for this lab is not very computational expensive. And then, as I said, we will install Docker, and then use Docker to run this opendronemap. You can install it on Windows, Mac, or Linux. So I'm using Windows, so I'll just follow the Windows instruction. So first step, you need to check the virtualization support. You can check it in the task manager. So basically, you can easily right-click on your taskbar and then go to task manager to see performance, to see if you have the virtualization here. So I am enabled. You can see I'm enabled here. If you don't have it enabled, I think the tutorial give you some hotkeys to enable it. So, and sort it by brands. So the next step is to install the requirements. First of all is Git. You can install it using this link. Then install Python. I believe many of you already have Python in your computer. If you don't, you can install the latest version of Python. I think so. As long as it's version 3 Python, it should work for this installation. Then you need to install Docker. If you use Windows 10 Home or previous versions, you need to download the Docker toolbox using this link. Otherwise, if you're using Windows 10 Professional or newer, like Windows 11, like me, you should install it using this link. And I think it will download installation execution, and you can follow the instruction on that execution. So next, step 3, check memory and GPU allocation in the Docker. So currently, I don't see this setting and advanced setting that allows you drag the bar to set up GPUs and memories. So I think you can skip this step for now. So let me follow the instruction. So right click, change settings. Oh, the exclamation mark just basically mean I need to download the updates. So let's go to resource advanced. I think it now requires a file to allocate the resources. Otherwise, it will, I think by default, it will use up all the resources of your computer. So as a container, it will not use all of the resources, but the container is at the same size as your computer CPU and memory. But it should be fine. As I said, the process we're doing today are not super computationally expensive. And then after your download, after your Docker is all set, you can now moving on to download the software itself, the web ODM. So by downloading, I mean it's just copying all the files in this GitHub repository to your local target directory. So as shown in this one, so you are cloning one online repository to your local folder. So for the first timer, you're going to click the clone existing repository and then just put in those two links. So the target directory, you can specify your own. You can specify your own path to your desired folder, either different drives or different paths. That's fine. But we are going to use this GitHub link. So once you've done that, I think this window will pop up, and then we're going to click git bash. So we're going to start our software by typing this command in the git bash. So ODM. And then wait for a while. It's initializing. Okay, once you see this, congratulations, and then you can open a web browser and navigate to this local host. So you can simply click control and click that, and then maybe type 8000 to that port. For the first timers, I think you need to, for the first timers, I think you need to register or sign up for your own account. Yeah, and we'll be asked to create the first user. Since I already done that, the next time I log in, it just asks for the username and passwords. So log in. So now we are successfully entered the software, the web ODM. And then this one, so I think for the first timers, you won't see this. You'll just have a blank dashboard and then add projects. So this one is just the test I did before. So the usual process will be add project, and then given a name, I'll name it as Mo video. And then create project. So you will import the data. Select the images and then see ground control points. And then you are going to select all the image in the folder. So this folder I got from Lane, and then I believe she will share you with the data, and you just need to extract it and then save to a directory that you can remember. For them, and everything is all good. So here we just select all the images and then open. It automatically have all the points where you collect the data, and then the name. So finish review, then start processing. So this process usually takes about 15 minutes. So we can expand the task I did before. So it is complete. The status is complete, and it took me 14 minutes. And then, so for the sake of time, we're just using this one as a demo. So you might notice that the disk usage is different. Is different, and then I think it will be updated once you create a project, once everything is done. So let's go to view map. So you can directly see the processed ortho photo here. Then we can zoom in, zoom out, and then maybe move a little bit, and then we can go to see plant health and surface model. You see the location of the cameras. Okay. Now we're going to go to the 3D module. So you can see all the points. So this is a 3D module, and you can navigate this area by either rotating or like moving horizontally. So if you like left click your mouse and hold it, it will be the rotating mode. And if you right click your mouse and hold it, it will be the moving mode. You can zoom in, zoom out by scrolling your mouse. And then here we can also see the cameras, texture. So it gives you a smoother view, not the individual points. And then, as I said, we can use tools to make measurements. So these are the examples that I tried before. So let me do another one. So you can see this has some heights measured here. So let me first measure the linear distance. So it already tells you the the distance. And then now we're going to make a height measurements, so approximately the same point. Then you can see the heights are measured from the starting point to the ground level. And then you can explore others like clipping. You can clip this pile out. And then I think there are many other features you can explore. I think I'm recording and also running the software at the same time. It's kind of laggy, so I'll skip those. So you can also enter the 3D modes from your dashboard. So you're not clicking view map, you're going to directly go to the 3D model. And I think if you want to directly go into the 3D model and use the tool, that's fine. So yeah, I think that's all I want to share for this assignment, because this software need to be run on Docker environment, and our departmental virtual desktops does not support that, which means maybe some of you could not do it on the departmental virtual desktop. So this assignment is not required, but it's recommended for you to explore, just given that you might not have ISRI credential after you graduate. So it's better to have some open source software experience. Okay. Thank you for watching.